Hello everyone, welcome to the channel Data Science with Harshit. My name is Harshit Tyagi. I'm a data science instructor and mentor. So this is the second part of the Python fundamental series. In the previous video, we covered the basic data types as well as some operations that we can perform on them, and we covered Python lists as well. So in this particular part, we are going to focus on 2D list, tuples, how to write conditional as well as use logical operators. And we're going to learn how to write loops as well as what is a proper method to write functions in Python. So Python fundamentals part 2 coming right up. So we have our Jupyter notebook running and we can head over to the browser and you can see this is the part 1 notebook that we worked on, and now I'm going to create a new Python 3 notebook for part 2. This takes a few seconds as we know. Alright, let's quickly change the name of the notebook. Fundamentals part 2. Alright, now the name is changed. So a quick refresher on lists, since we are going to start off with 2D lists. So let's say this is our list. A list, as we know, this is an ordered sequence again. So Tom 54, it can have any data type. So let's say Julia, comma, another score, let's say 78. Alright, so this is our list and let's run this. Shift plus enter, a list. Let's see if we have it all in the correct form. Alright, awesome. So this is our list, and also we learned that we can append something. So let's append a function. Let's append the help function which is built in the Python language. So let's run this. Again, check what do we have in the list. So this help function is basically type help for interactive help. So this is another like really good function that you can use to learn about any keyword, any function. So let's say I want to learn about sum. Can we have something about sum? Yeah, so it returns the sum of the start value plus an int variable. So yeah, and in case you want to quit it, just type in quit, and yep, the function has quit. So that was great. Now let's head over to 2D lists, and so let's say this is there's a list called B lists. Okay, and we can define a 2D list like this. So let's say we have first is Tom, comma, Tom's score, let's say is 54. Then add a comma after this and another list, Julia, with 78. So this is basically a 2D list. How I can define, there are a bunch of ways to define a 2D list, and if I look at so let's run this B lists. Okay, so this is basically our 2D list, which is basically list of lists, and in case you want to access any element, so we have columns as well as rows, just like in any 2D array. So in case you want to access the first row, so you can simply mention B list, square brackets, and the index 0. This is the first list that it's going to give you. Okay, B lists, sorry, the name, yeah, so B lists. So I've got the first row, which is this row over here, and in case I want to access the first element, which is 0, 0, so I can add another square brackets, and if I want to access this Tom, so this is 0, 0, and if I want to access Tom's score, I can mention 0, 1, 0 or 1. So I've got the first or the second element of the first row. So this is basically how I can access and work with 2D lists. Also, in case you know that negative indexing really works, so negative -1 means that it starts from the end. So -1 means the last element of your list. So it works in 1D list as well, basically simple Python list, and 2D list as well. And slicing also works the same way in 2D lists. And yep, so in case you want to get B list -2, 0, that will also give you the first element, Tom. So big, since we have only 2 elements in this particular list. And also the append functions also would work the same way. B lists, append, I want to append another name, let's say Mac, his score is 90. So yeah, let's check what do we have in B list now. So we have 3 elements. So that's basically how lists works, a 2D list work. And this is a simple method. Again, another way to define 2D lists is let's say there's another list called A. I have a bunch of zeros in it, which is, and let's say I multiply it by 5, so I'll basically get 5 zeros in a 1D list. And let's check. So I have 5 zeros in a 1D list, and in case I want to convert it into a 2D list, so you can simply do, so yeah, if I say calls equals 5, rows equals 5 as well, or let's say 4. So I create another list, 2D list, which is, let's say 1, and 1. I want number of columns, and this is calls, and I want to multiply it with rows. So I want 4 rows and 5 elements, 5 ones. So this is what I want, and let's run this and check what do we have in our D list. So basically, as you can see, this is how our 2D list has been created for us. So this is 5 columns basically, and we have 4 rows. So let's look at tuples now. So tuples is also a compound data type like list, and it's an ordered sequence which contains comma separated values inside parentheses. So this is basically, let's create a tuple. So again, let's put Tom his score. So this is Tom, this is his score, let's say 78. So these are values inside parentheses. An important thing about tuple is why they are different from list is they are immutable. We cannot change them. So and everything else like indexing. So if I want to access the first element, so indexing works just the way it works in list. And if I want to access the first element, and this is how I can do it. If I want to change this 78 to, let's say, something else, 90, I want to change the score of Tom. So if I run this, so this gives me an error that object does not support item assignment, which means that tuple cannot be changed. Let's go create another tuple. Let's say, let's put Julia, her score, let's say 89. And if we add these two tuples, so let's see what it gives us. So we have Tom 78, Julia 89. So we have added these two tuples, but it doesn't mean that we have changed either of those. So you can check that tup1 is still Tom 78. But what we can do is we can store this addition, this particular tuple, in another variable called tup3, tup2. So if you run this, now tup3 will be your updated tuple, the new tuple, and everything else, the functions, like you can learn about the length of your tuple, like this tup3, and this gives you the length of your tuple. So another important data structure is dictionary. This is a Python inbuilt data structure for mapping keys to values, and the syntax simply looks like this. Let's say we have country code, and it has curly braces. So I have country names, and so this is basically my key, and I have a value corresponding to it. So the code of India is, let's say, 1, then code of USA is, let's say, 2, then add China as 3. So basically this is how these are keys, and they have their values mapped corresponding to them. And if I print country code, so this is how it prints our dictionary. And if we want to access any particular value, we can do that using the keys. So country, so it uses the square bracket syntax similar to indexing, which is in list and strings. So let's say I want to access China's code. So this is, let's put this in print. So China's code is 3. Another thing that I can do with dictionary is I can add, let's say I want to add UAE's code. So I can create a new key, UAE, and I can add the value. So let's say 4. And if we print our updated dictionary, so it should have UAE appended. And you can also check if something is available inside your dictionary or not. We're going to go into conditionals next. So this is just like, let's say if you want to check if India is present in your dictionary. So if India in country code, so this basically gives you a boolean, true or false. So India is present. For conditionals, we'll have to understand what is boolean. So Python has a type called bool, which can take on 1 or 2 values, true or false. So let's say we have a variable which is x equals true, and if we want to check the type of x, this will be a bool. So bool, basically x is our bool class object. And if we want to check, so let's say we want to compare two values. Let's say if you want to check if 1 equals 2, so this will print false for us. So 1 is not equal to 2. So if I check 1 equals 2, so this gives me false. And if I put 1 not, which is not is basically denoted by this exclamation mark, 1 not equals 2, so this would give me true. Right? It basically helps you write some conditional statements. These are a few comparisons that we can do. So the comparisons operators are simply, I have a equals 1, b equals 2, I can do a equals b, and let's just print each of them. A equals b, greater than equals, less than equals, and not equals. So a equals b, false. A like greater than equal to 1 is not greater than 2, so that is also false. A less than equal to, yes, that is true. And a is not equal to b, so that is also true. We can do a bunch of comparisons. We can also remove these equal to signs and then run all of them. So yeah, these are the comparison operators that we can use. And now moving on to writing conditionals. So how to write your conditional statements. So let's say we have a variable called color, and we have color equals red. Now let's say I want to check if the color is red or something else. So I can simply do it by using the if keyword. I have if color, which is my variable, if color equals red, then colon indented, and I can simply print that my color is red, and then I can simply print at the end that my color problem is solved. So if I run this, so let's say, so I have so my color is red and this conditional statement has turned out to be true. So this has returned true. Color equals to equals has returned true. So the value, basically the conditional statement has been satisfied. It goes inside this block of code as this is indented. So it goes inside and it prints color is red, and then it comes out, and this is my statement outside. So color problem is solved. It is printed at the end. Now let's say I want to check if let's change the color to green, and let's copy paste this here. I want to add, so if my color is not red, then what should I print? So I'll print that color is not red. So this is the else keyword. So if this particular statement doesn't turn out to be true, then I want the code or the system or the program to go here. So if I run this, so you can see that color is not red. My else statement has turned true, and if it would have been red, so color is red, this is true, and my program comes out and prints color problem is solved. And if it is something else, let's say this is something else, so it prints like this. So let's say I want to add some more conditional statements, so I can simply use elif. So I can put in elif, which is short for else if. So elif color equals I am checking for green now, then print color is green. So now if I run this, it should print color is green, and then your problem is solved. So this particular statement has turned true. This is false, it won't go into else since this elif statement has turned true. The program control goes here, prints color is green, and then comes out and prints color problem is solved. That was about how we can use for strings. And another way that you can use a conditional statement is, let's say age equals 15, and I want to use the comparison operator. If age greater than or equal to 18, you print adult, else you print juvenile. Alright, so age is 15, this has turned false, program control goes into else and it prints juvenile. So this is basically how we can use the conditional statements. Now another thing that we need to learn about is the logical operators, basically or, and not. So let's learn about how these work. So let's say I have my variable called 0, and if I add it to not, so not a means the opposite, so it inverts, so this gives me true. 0 stands for false, 1 or any other value stands for true. So a equals, let's say if I have 1 or any other value, let's say 3, so not of a would give me false because this is true. Or if my a would have been true, so this not of a would have given me false. So not of a gives me false. Now or, coming to the or keyword, so let's say I have my score equals 76, percentile is equal to 83. If score is greater than 75, I can use it inside a conditional statement. If score is 75 or the percentile is greater than 90, I say that admission successful. Else I say print try again next year, all in double quotes. So if I run this, so I have my score greater than 75, so percentile greater than 90, so this is basically true. So any of my condition, either this, if any of these is true, the whole conditional statement would turn true, and the program control would go inside this block. So my score is greater than percentile is less than 90, but still my score is greater than 75, so this has turned true. If I would have mentioned and here, so and requires both of the conditions or all the conditions to be true. If I would have added and run this, so this would have given me, so this would have turned out to be false, and the program control goes to else and prints try again next year, since it requires both this condition as well as my percentile condition to be true, whereas or requires either one of these to be true at least. So let's talk about loops now. Now, loops is just another way of doing something repeatedly so that we don't have to write a piece of code again and again. Now, before we talk about loops, we shall understand what a range function is. So this range function, it creates an ordered sequence just like a list. So if you give this number, let's say range 5, and we call this, so this creates a range of 0 to 5. Now this 0 is inclusive, but 5 is not inclusive. So it starts with 0 but ends at 4. So let's say the syntax for a loop is, for a for loop is, so you write a for, let's say a variable called I, an iterator, in range called 5, let's say range of 5, and I want to inside this loop, so this is my loop definition, and I go inside and I print my iterator, print I, so this will basically print the entire sequence. And if I run this, so this prints from 0 to 4. So I said the 5 is excluded, so since it starts from 0, so I have 5 elements, so all of them are printed from the sequence that this range function created. So this is basically one way of creating this loop, and inside this loop I can do a bunch of tasks, not just print. So let's say for I in range 5, I want to print, let's say I want to calculate product equals I, or let's say 8 star I, multiply everything. So this gives me multiplicative factors of 8. So you can also mention the starting value, let's say 1. I want to start my loop from 1. I want to take it up till 2, and I want to mention the step size as well. So let's say 2. So now this loop will start with 1, and the jump size, the step size is 2. So from after 1 it'll go to 3 instead of 2, and it'll end at 9, not at 10 but 9, since this 10 is excluded. So now if I do the same thing and print this, so this is 8 into 1, then 8 into 3, then 8 into 5, and 8 into 7, and 8 into 9. Let's create a tuple called names. Let's put Harshit, comma Shubham, comma Sahil. Another way that you can iterate over a list or a tuple is that I can simply use the list or the tuple for name in my list or my tuple. For name in names, I can simply print the name. These are all strings. Let's convert them into uppercase. So if I run this, so you see it goes to each of those elements. It picks up each of these elements in the list or the tuple, whatever that you have, and it converts each of these strings into uppercase and prints them. Now to use while loop, let's create a list age with some numbers 1, 12, 43, 50, 45, and 10. And now let's start a variable I with 0. I have initialized this variable I with 0. Then I write while. So this is basically the syntax. While I mention the conditional statement where I want to break it. So while I is length of age. Length of age is my length of my list, this list of ages that I've created, colon, I enter into the loop. So then I put a conditional statement here. If age of I, this is how I access my list element. So if age of I is greater than equal to 18, I print adult, else I print juvenile. So this, if I run, and the last thing that you have to take care of is you have to increment your iterator variable. So this I is our iterator variable. We have initialized it with 0 and it'll go up till the end of this list. So I'm basically iterating over the list and it'll check if I is up till the length of age, and I'll keep incrementing my iterator with 1. So if when I run this, so this what happens is this I is 0 here, and length of age, length of this list is 4. So 0 is less than 4, so that is true. Now inside I go, so I is currently 0, age of 0, this is the first element. 12 is greater than equal to 18, so that is false. So it goes into else, prints juvenile and increments my iterator variable by 1. So I is now 1, goes again, I is 1 now, it is less than 4, age of 1, which is 43, is greater than equal to 18. So this condition turns out to be true. So I have juvenile for the first and the last element, which is 12 and 10, and adult for the other two. So this is basically how I write my while loop. So now that we have covered loops, so there's an important concept of list comprehension, which you will come across quite often. So list comprehension is one of Python's most beloved and unique features. So you can, this is just another way of defining your list. So let's say you want to store squares or cubes in a particular list. So how you can create a list is you can simply do n star star 3 for n in range 1 comma 10. So if let's say I wanted to create this list where I am storing the cubes, so this will keep storing my cubes in my list, keep appending them, and if I see what is inside my cubes, so this is basically what my cubes list looks like. So this is list comprehension, where I have mentioned what needs to be stored here and then the for loop ahead of it. So if I would have done it like simply, so this would have been for I in range 1 comma 10. So there is a list called cubes, and this list is cubes dot append I star star 3, and if I would have printed cubes now, so this would have given me the same results. So this is what list comprehension does in just a single line of code. So let's talk about functions. We've seen and we have been using functions such as print, range, length, append function. So Python has many more built-in functions, and also we can go on and define our own functions, which is the big part of Python programming. So whenever you come across a new built-in function, what you can do is, and you don't know what that function does, you can simply run help function over that. So let's say we don't know, there's a function called absolute ABS, and we don't know what it does, so you can run the help function. So it tells you that it returns the absolute value of that argument. So if I run absolute over an expression, let's say 2 minus 5, so 2 minus 5 is minus 3, but it gives me the absolute value of minus 3, which is 3. So we can use help function and absolute function like this. So there are many other built-in functions in the Python language. Let's talk about how we can define our own functions in Python. The syntax basically looks like this. So we have a keyword to define, which goes in the header of our function. So define. So let's say let's create add two numbers, and it takes arguments, which is basically the input. So function is, it takes input and it processes it, just evaluates a few expressions and then gives you the output. So add two numbers, it'll take two numbers a comma b, then it'll calculate the sum a plus b and then return this sum. So this is our function, add two numbers. Let's call this, run this cell, add two numbers and then pass on 5 comma 11, let's say. So this gives us 16. So it has rightly evaluated the expression a plus b and given us this result. So this is basically how we can define our own functions. Now this a plus b, we could have done something more complex. This return, we have some important things here. So this is our function header, which is basically, which contains the def keyword. Then another important keyword is the return keyword. Whenever this is encountered, our function basically gets over and it gives you whatever the result is at that point of time. This is the body of our function, and these a comma b are the arguments that the function takes, or the input that the function takes. This is basically what function looks like. So let's try to write a function in the best possible manner. Fahrenheit temperature to Celsius, and then pass on the temperature inside. Now anytime you write a function, you should document your functions like these. So these are called doc strings. Anything that you write between these would be commented. This is not code, this is the documentation of your function, which basically you write so that whosoever reads your code should be easily able to understand what this function does, what it takes as input, what it returns as output. This is basically what my function does, and I have the arguments defined, I have the returns statement defined. So now I am going to do the calculation. So temperature in Celsius is equal to, so the formula is basically temperature minus 32 multiplied by 5 by 9. So this is my, and then I return temperature in Celsius. So this function basically converts temperature from Fahrenheit to Celsius. Now if I call this, let's see what is 50 degree Fahrenheit in Celsius. That is just 10 degrees Celsius. Oh, that's awesome. So this is basically what functions do. So you can all define like really complex large functions, and this is what you are going to do when you go into solving data science problems. There'll be a bunch of things that you'll be doing inside a function, but the important thing that you have to keep in mind is that you should be focusing on defining what the purpose of that function is, what it does, what it takes as input, how to define your doc strings. So those are the important concepts of writing functions. So you've seen how do 2D lists and tuples work, how to write loops, conditional statements, branching statements, how does slicing works, and how do functions work in Python, and what is the best way to write functions. So at this point, watching this video is just not enough, and you'll have to practice all these concepts. So for that, I have prepared an assignment which you can use to practice, and I've added the link to the GitHub repository as well as the Google Collaborative notebook that you can use to practice. Also, that might not be enough, so you can head over to platforms like LeetCode, HackerRank, or Coding Ninjas, where you'll find basic or moderate level problems that you can use and practice. So in the next part, we'll be covering object-oriented programming, modules and packages. How do we write code? How do we use code written by others? So if you have found this video useful, do not forget to like the video, and feel free to add any thoughts, comments, suggestions in the comment section below. and make sure that you subscribe to the channel so that you don't miss out on all the upcoming videos. Part 3 is coming out soon. So till then, stay tuned and keep learning data science with Harshit. Cheers.